Okay, so now you know what a programming language is. A translator between you and the computer. But here's the thing. There are hundreds of programming languages out there. Hundreds. And that's honestly a bit overwhelming when you first see it. And the good news? You don't need to know all of them. You just need to understand how they're organized. Because once you see the pattern, it all starts making a lot more sense. Let's start with the most important split. Some programming languages sit very close to the machine. You're basically writing in a way the computer almost directly understands. Imagine you wanted a computer to draw a star. One way would be to tell it exactly where every point goes. Draw this line. Then this one. Then this one. These are called low-level languages. And then there are languages that sit closer to the human side. Or you could simply tell the computer, draw a star, and let it figure out all the lines for you. These are called high-level languages. High-level means closer to humans. Low-level means closer to the machine. But here is a common misconception. High-level doesn't mean more powerful. And low-level doesn't mean outdated. Neither is better. They're just built to solve different problems. Now, you might be wondering, if high-level languages are easier, why does low-level even exist? Think about a race car versus your everyday car. Your everyday car is comfortable, easy to drive, gets you where you need to go. But a race car? It is raw, stripped down, built for one thing only: speed. Low-level languages are the race car. They give the programmer extreme control over exactly how the computer uses its memory and speed. And in some situations, that control is everything. Things like operating systems, video game engines, tiny microchips inside medical devices. These need every bit of performance they can get. But for most people, and most projects, high-level languages are what most developers use day to day. Because when you are building a website, or analyzing some data, or making a simple app, you don't want to be worrying about memory management at every step. You just want to get things done. And high-level languages let you do exactly that. You focus on the problem you are solving, not the machinery underneath. There is one more way to think about programming languages. That is actually really useful to know. Imagine you buy a French book that has already been translated into English. The hard work happened beforehand. So when you open the book, you can read it immediately. Now imagine the book is still in French. As you read each line, you use a translation app to translate it on the spot. You're constantly translating and reading at the same time. Languages that translate everything first are called compiled languages. Languages that translate on the fly are called interpreted languages. The compiled version tends to run faster, because all the translation happened before you even started. The interpreted version is more flexible. You can make changes and run the code almost instantly. So where do real programming languages fit into all of this? Some languages are high-level. Some are low-level. Some are compiled. And some are interpreted. The important thing isn't memorizing every single language. It's understanding the trade-offs behind them. And that's why there isn't one best programming language. Different tools, different jobs, different trade-offs. The best language always depends on what you're trying to build. So now you know how programming languages are organized. Next, we're finally going to choose a language to build with. Let's go.